Hello guys, welcome back to my YouTube channel. I am Likith DG. I am studying Shivangateshwar College of Engineering, Vijayanagar, Bengaluru, in the Department of Computer Science Engineering and Data Science. And today I am going to give some information about Latin square and analysis of covariance, which comes under the subject Mathematics for CSE stream. Its subject code is BCS 301. Let's go in these slides. We are going to see the contents are Introduction to Latin square design, types of Latin square, analysis of variance, implementation of Latin square design, challenges and considerations, case studies and practical applications. Let's start with the first topic, Introduction to the Latin square design. Overview of the Latin square design. Definition of Latin square design. Latin square design is a statistical method used to control of two different type sources of variability in an experiment. It arranges treatments in a square grid such that each treatment appears exactly once in each row and column, ensuring that effects can be separated from those of other variables. Historical background. The concept of Latin square design dates back to the 18th century with the con- with contributions from mathematicians such as Euler. It was initially developed from the agricultural trials and has since expanded into various fields including physiology and clinical research as a robust means of experimental design. Key characteristics. Structure of Latin square. Latin square consists of n rows and n columns filled with n different treatments. Each treatment appears only once in each row and column, allowing for a balanced comparison across all combinations of treatments. Advantages of Latin square design. The Latin square design effectively controls for variations when working with a limited number of experimental units. Its structure reduces experimental error and allows for more precise estimates for treatment effects, enhancing the reliability of results. Let's move on to second subtopic, types of Latin square designs. Basic Latin square design. A standard Latin square and balanced Latin square. A Latin square is used more in most common form, utilizing a equal number of treatments and blockful grid arrangement. Each treatment is randomly assigned to the cells in a way that fulfills the necessary conditions of the design. Balanced Latin square. A balanced Latin square is a variation which treatments are arranged in a way that are balanced interactions among treatments and blocks. This design seeks to weigh exposure evenly across the different levels of blood factor. Variations of Latin square designs. Partially balanced Latin square and randomized Latin square. These variations allow for certain treatments to be replicated more than once while still adhering up to some Latin square constraints. It accommodates designs where not all combinations of treatments are available. Randomized Latin square. The randomized Latin square incorporates random assessment of treatments to all the square cells. These variations help us to mitigate bias by ensuring that any synthetic error does not consistently influence the results. Analysis of variance. Analysis of variance is also known as ANOVA. Introduction to ANOVA. Definition and purpose. Analysis of variance. ANOVA is a statistical method used to test difference between two or more group means. It helps determine if the observed variance is sample groups can be attributed to true differences among populations rather than the random choice. ANOVA in Latin square. One-way ANOVA and two-way ANOVA. One-way ANOVA is applicable in Latin square designs to assess the impact of one treatment factor while controlling for variability in two blocking factors. It is effective for analyzing treatments difference in controlled experiments. Two-way ANOVA in Latin square contents. Two-way ANOVA extends the analysis by examining the interactions between two independent variable factors with the Latin square design providing a deeper understanding and how these interactions may affect outcome variables. Data collection and analysis. Data collection of data collection in Latin square designs requires meticulous documentation of responses to each treatment. This phase may involve utilizing questionnaires, sensors, and other methods to quantitatively and qualitatively capture the outcome of interest. Statistical analysis and techniques. Following the collection, statistically analysis techniques such as ANOVA are employed to evaluate the treatment effect. Proper analysis of ANOVA assumption testing, interrupt variations and variance and statisticals. Challenges and considerations. Common challenge. Design limitation. Limitation of Latin square design can include difficulties in accommodating more than two blocking factors or treatment interactions which can compromise the validity of conclusion drawn from the analysis. Implementation issues. Challenges may arise during implementation, such as ensuring random assignment of treatments, managing sample size constraints, and addressing unanticipated experiment conditions that could skew results. Mitigation strategies. Best practices. Best practices in conducting Latin square design involves pre-testing the design, maintaining consistency in experimental conditions, and ensuring rigorous training for data collectors to minimize biases. Alternative designs. When Latin square design faces significant limitations, researchers may consider alternative designs such as factorial designs and randomized block design, which can provide more flexibility and control over variability. Case studies and practical applications. Real-world examples. Agriculture experiments. Latin square design has been effectively utilized in agriculture studies to test the effect of different fertilizers on crop yield while controlling the field variability. This approach ensures that the results are statistically reliable and actionable. Clinical trials. In clinical research, Latin square designs enhances the ability of evaluate the efficiency of treatments to research and compare the medication dosage while maintaining. Thank you for watching this video. Please like this video and subscribe.